In this video, I will demonstrate how to create the design of exercise 1 in chapter 2. Let's take a look at this design. This design is very interesting because it contains many circular shapes. We have a couple circles and quite a few arcs. There are also quite a few implied geometric properties, mostly tangency. There are 3 key locations in this design, and they are the center points of these 2 circles and the center points of these arcs up here and down here. As far as creating this design goes, we must first locate these 3 points. Let's begin. First, switch on the snap option and the grid option in the status toolbar. So we'll use the circle diameter command, and we're going to use the same techniques that were demonstrated in the tutorial. We'll begin the design right at the world origin. So read the coordinate display at the bottom of the screen. Select the center point of the circle to align at the origin of the world coordinate system. And we're going to create 2 circles at this location. The first circle's diameter is 1 inch, so type in 1 and hit enter. And we'll use the same command again. So go to center diameter circle command and go right to the origin, and the diameter of the circle is 2 inches. Next, we'll create 2 circles using the center radius option. Now notice that our last point was at the origin. Now I could switch to using the relative polar input method. We want the circle to be located at 3 inches and at a 40-degree angle measured from the origin. Enter at 3 angle 40 and hit the enter key once. The radius for the circle is 0.5 and hit the enter key once to create the circle. We'll create another circle at the same location. Activate the circle command and enter at 0, 0. This will position our center point at the same center point of the circle we just created. The radius we want for the outside arc is 1 inch, so type in 1 and hit the enter key once to create the circle. We'll just repeat this process to create the other 2 circles. I'm just going to hit the space bar, which is a quick key to repeat the last command. The center point of this next location needs to be exactly 3 inches away from the world origin. We'll use the absolute input method to position the center point at the correct location. Type in 3, 0 and hit the enter key once. The radius for the circle needs to be 0.5 and hit the enter key once to create the circle. Hit the spacebar once to repeat the circle command. Now, since I do have the snap and display options switched on, I can create the next circle by using the interactive method. Move the cursor to x equals 3, y equals 0, and left mouse click once to position the center point. The radius is 1 inch, so move the cursor towards the right, measuring 2 grid points. Left mouse click once to create the circle. Next, we need to create some arcs that are tangent to the 6 existing circles. Let's first switch off the snap option so that it's easier to select existing objects. Generally, it's a good idea to leave the display option switched on so that we have a rough concept of the size of objects we are drawing. AutoCAD provides quite a few options to create arcs, but since we need to have the arcs tangent to the existing circles, we will use the circle command instead. We will use the tangent radius command to create a circle tangent to 2 of the existing circles. Activate the tangent radius circle command. We want it to be tangent to this bottom left circle. Notice I'm going to select near the tangency where the two circles should touch. How we select determines how the circle will be constructed. The second circle is this one, so again select near the tangency location. Now the radius for the circle is 5 inches. Enter 5 to create the circle. We will repeat the same steps and create another circle tangent to the two circles. Choose the tangent radius circle command. The tangency to the bottom left circle is roughly near the lower portion of the circle, so we're going to select near that location. For the second circle, select the lower portion of this circle as well. Enter 3 as the radius. We just repeat these steps and create 4 more circles. For the outside tangent arc, we will still use the tangent radius command. We are going to have the tangency at roughly near the top right of the top circle. Left mouse click once to select the circle. Now select the lower right circle near the lower right side. Enter 4 as the radius and hit the Enter key once to create the circle. Repeat the same steps and create the next circle, which has a radius of 3.5. Again, choose the circles near the tangency. 2 more circles to create, radius 2.5 and 2. Now we have created all the circles we need. What we need to do now is remove the portions we don't need, and we will use the trim command to do this. Activate the trim command. AutoCAD expects us to first define the trimming boundary. Now, if we do not select anything, AutoCAD will use all the existing objects as trimming boundary. Usually, it's a good idea to choose trimming boundary. This will reduce the number of trimming we need to do. I'm going to choose the original 3 circles as my trimming boundary, and right mouse click once to accept the selection. Now select the portions of the circles that we do not want to keep. Press the spacebar once to end the trim command. Hit the spacebar again to repeat the trim command. Choose the 2 smaller circles on the right and choose the 2 arcs on the right as the trimming boundary. Right mouse click once to accept the selection. Now we'll trim the portions of the circles we do not want to keep. Press the spacebar once to end the trim command. 1 more trimming to go. We'll need to trim portions of the 2 smaller circles. So hit the spacebar to repeat the trim command. Choose these 2 inside arcs as the trimming boundary. Right-click once and select the inside region of the 2 smaller circles. Hit the spacebar to end the command, and we have completed our design. Chapter 2 concentrates on the use of some of the basic construction and editing tools that are available in AutoCAD. To begin, we will first switch on the dynamic input option. So move the cursor to the status toolbar and switch on the dynamic input option. The dynamic input option is part of the AutoCAD heads-up design system, which can help us much more quickly to enter the information into the CAD system. So we'll use the line command to demonstrate this. Click on the line command and we'll position the first point near the lower left-hand corner of the graphics window. With the dynamic input option switched on, we get additional boxes next to the cursor. The numbers in the 2 boxes represent the length and the angle, which means we're using the relative polar input method. So let's say if I want to create a line that's 20 units long. Enter 20 and hit the Tab key, and I want it to be at a 30-degree angle. Enter 30 and hit Enter. AutoCAD will create the line that is exactly 20 units long and at a 30-degree angle. I can also switch to using the relative Cartesian coordinate system with the dynamic input option. Let's say I want a line that is 15 units in the X direction and 20 units in the Y direction. So enter 15 in the first box and hit the comma key once. This will switch to using the Cartesian coordinate system, and then enter 20 for the Y direction. Hit the Enter key once and the line is created. We can also use the direct input method with the dynamic input option. Let's say if I move my cursor in this direction and enter 25 as the distance. Hit the Enter key once and the line is created. The dynamic input option is a very convenient tool that allows me to concentrate on the screen and not the keyboard. To end the line command, right mouse click once to bring up the option list and choose Enter. In AutoCAD, the mouse wheel is also used to control the display in the graphics area. Turn the mouse wheel and we can zoom in or zoom out. And we can pan by pressing down the wheel and dragging the mouse. These are what is known as the dynamic view function that can be used to adjust the display of the constructed entities. The first thing we should do in creating a design using a CAD system is to set up the units. AutoCAD provides several options to set up the units for different types of designs. One of these options is to use the AutoCAD Startup option. Let us switch on this option by typing the word Startup. As we type, AutoCAD will display a list of commands matching what we are typing. This way, it is much easier to locate the command we want to use. Choose Startup in the list. By default, the startup system variable is set to 0, which means to start a drawing without using any predefined settings. Enter 1 and this will change AutoCAD to start drawing with the Create New Drawing dialog box. This will allow us to choose from many options during startup. One of these options is the basic choice of using either English unit or metric system when we start a new drawing. To show the effect of the startup system variable, click New File in the Quick Access toolbar. Notice now we have the Create New Drawing dialog box when we start a new drawing. There are 4 options available. The first one is Open an existing file. The second one is Start from scratch. The third one is Use a template. And the fourth one is Use a wizard. Depending on the design we are creating, we might use the basic option or the more complex Use a wizard option. For our design, we will use the basic option, which is the Start from Scratch option. Choose Metric under the Start from Scratch option. This will load the set of predefined settings that is generally used for metric designs. Let us take a look at some of the settings that are included with this setup. Go to Format, Units. Notice the length units set to millimeters. Let's change the precision so that no digit is displayed after the decimal point, which is typical for the metric system. Click OK. Next, we will look at the settings for the grid display and snap spacing. In the status toolbar, right mouse click on the snap mode option to bring up the option list and choose settings. Notice that for the metric system, AutoCAD automatically sets up the spacing for the snap and grid display to 10 millimeters. Turn on the snap and grid display options by clicking on the checkboxes on top. Click OK to accept the settings. The Start from Scratch option provides a set of basic settings that are commonly used. For more complex setups, we can use the Use a Wizard option or define our own templates. The use of these options are illustrated in the later chapters of the book. For the rocker arm design, we will also set up the drawing limits. Go to Format, Drawing Limits. For the lower left-hand corner, enter -200, -150. Hit Enter. For the upper right corner, enter 200, 150. Hit Enter. Notice the display is not adjusted until we execute one of the view-related commands. Go to View, Zoom, All. The origin is now located at the center of the graphics window. Let us take a look at the rocker arm design. The design contains several types of entities: arcs, circles, lines, and polygons. And there are 3 key locations for the different geometry. The center of the design, which is the center point for the 2 larger arcs, the center point for the arc on top, and the center point for the circle and arc at the lower left side. We will first construct the circular geometry located at these 3 locations. Activate the circle command using the center radius option. The center point of the first circle will be aligned to the origin, and the radius is 50. Hit Enter to create the circle. Activate the circle command again, and move the cursor to x = 70 and y = 50. Click once with the left mouse button to set the center point at this location. And the radius for this circle is 25. Besides using the icons in the toolbar, we can also repeat the last command by hitting the spacebar. Now move the cursor to x = -50 and y = -60. Notice that with the dynamic input option switched on, the coordinates are displayed next to the cursor. Click once with the left mouse button to set the center point at this location, and the radius for this circle is also 25. AutoCAD also provides additional toolbars that we can use. Toolbars are command icons organized based on their functions. Go to Tools, Toolbar, AutoCAD, and select the Object Snap toolbar. Notice AutoCAD displays an additional toolbar on the screen. The Object Snap toolbar contains the Object Snap options. Move the cursor on top of the icons and read the pop-up descriptions to get a sense of the available options. The more commonly used ones are the Snap to Endpoint option, the Snap to Midpoint option, the Snap to Center Point option, the Snap to Tangent option, and the Parallel and Perpendicular options. For the rocker arm design, we will next create the 2 lines that are tangent to the circles. Activate the line command. Notice in the command prompt area, AutoCAD indicates the line command has been activated. And although AutoCAD expects us to indicate the location of the first endpoint of the line segment, we will use the Snap to Tangent option. Click on the icon in the Object Snap toolbar. AutoCAD will now wait for us to select an object to apply the selected Object Snap option. Select the center circle near the top of the circle. We want to select near the tangency location where the line is going to touch the circle. AutoCAD does not attach the first endpoint yet, as the location of the tangency will be determined by the location of the second point. Choose the Snap to Tangent option again, and select the circle on top. Select near the top of the circle. Hit the spacebar once to end the line command. Notice the line created is exactly tangent to the two selected circles. Hit the spacebar again to repeat the line command, and we will repeat the same procedure to create the other line. Choose the Snap to Tangent option. Select the circle towards the left. Select near the left side of the circle. Activate the Snap to Tangent option again. Select the circle at the center. Select near the left side of the circle. Hit the spacebar once to end the line command. Next, we will create two arcs that are tangent to the circles. Although AutoCAD provides several options to create arcs, the circle command is more suitable for the tangency situation. Activate the circle command and choose the Tangent Radius option. The Tangent Radius option requires us to create a circle that is tangent to two existing objects with a known radius. Select the top circle near the bottom of the circle. Select the center circle near the right side of the circle. Again, we want to select near the tangency. The radius of the circle is 50. Hit Enter. And AutoCAD has created a circle that is tangent to the two selected circles with a radius of 50. Hit the spacebar to repeat the last command. Notice that AutoCAD will reset the circle command back to the default option, which is the Center Radius option. Right mouse click once to bring up the option list and choose Tangent Radius. Select the circle towards the left. Select near the right side of the circle. Select the center circle near the bottom side of the circle. Type 40 as the radius. We have created another circle that is tangent to the two selected circles with a radius of 40. We are ready to complete the outline of this design. We will do this with the Trim command. The Trim command is located in the Modify toolbar. AutoCAD allows us to trim or extend objects. The Trim command will shorten objects to the selected boundary, while the Extend command will lengthen objects to the selected boundary. Activate the Trim command. Now AutoCAD expects us to first identify the trimming boundary. Let us select the line on top in the larger circle towards the right. Click once with the right mouse button to accept the selection. Now click on the left side of the top circle, the portion we don't want to keep. Select the right side of the center circle. AutoCAD will adjust the selected objects so that they are shortened exactly to the selected boundary. Right mouse click once to bring up the option list, and choose Enter to end the Trim command. Hit the spacebar once to repeat the last command. Now, if we do not select any trimming boundary, AutoCAD will use all of the existing objects as trimming boundary. Let us try that. Click once with the right mouse button. Select the center circle on the left side. Select the left circle on the top side. We will select the two Tangent Radius circles on the right side. We have completed the outline of this design. Right mouse click once to bring up the option list and choose Enter to end the Trim command. For our design, we still need a hexagon at the center, a square on top, and a circle at the bottom. Activate the Polygon command located in the Draw toolbar. It is in the same stack as the Rectangle command. With the Polygon command, AutoCAD first asks us to identify the number of sides. Enter 6 for a 6-sided shape. Move the cursor to align to the origin. Click once with the left mouse button to select. AutoCAD asks us to identify the Inscribed in Circle or Circumscribed About Circle option. AutoCAD actually uses a circle to control the size of a polygon. For our design, we are going to indicate the flat to flat distance, so choose Circumscribed About Circle option. Now, as I move the cursor around, you will see the size measurement is from the center to the edges, the perpendicular distance. If we choose the Inscribed option, the size measurement is from the corner of the polygon. So imagine there is a circle inside the polygon for the Circumscribed About Circle option, where the Inscribed in Circle option would have the circle pass through the corners of the polygon. Enter 30 as the radius of the circle to create the polygon. Hit the spacebar once to repeat the last command. This time we will create a square, so enter 4 and hit the enter key. Now we need to position the square to align to the center point of the upper arc. We will use the Snap to Center option, and we will touch the arc on top and notice the center of the square is aligned to the center point. Choose the Circumscribed About Circle option. Move the cursor towards the right side, one grid point away from the center. Click once to create the square. The last geometry we need is a circle. Activate the Center Diameter Circle command. Activate the Snap to Center option. Select the bottom arc. Enter 20 as the diameter. And we have completed the rocker arm design. In this video, I will go over how to use the basic geometric construction and editing tools to create the design of Exercise 1 in Chapter 3. Let's look at the design. The design consists of quite a few squares at the center and many equally spaced parallel lines. To create this design, my plan is to first create the squares aligned at the center using the Polygon command, and then use the Line command and the Offset command to create the parallel lines. Let us begin. Go to Format, Units. We'll set the length option to decimal and showing 2 digits after the decimal point. Click OK to accept the settings. In the status toolbar, switch on the Snap option, the Grid Display option, and also switch on the Dynamic Input option. We'll first use the Polygon command to create the squares aligned at the center. Choose Polygon in the Modify toolbar. It is in the same stack as the Rectangle command. We will first create a square, so enter 4 as the number of sides of the rectangle. We can also specify the method to create the polygon. The two options are specify the center of the polygon or use the edge option. Let's use the edge option. This option will allow us to specify the edge length of the polygon. Choose edge. We will create our design at the center of the screen. Select a location near the center of the screen. The edge option allows us to indicate the length of the polygon with the mouse or using the keyboard. We'll use the relative coordinate input method. So at 3, 0, we have created our first square. Let's switch off the snap mode so that it is easier to select objects on the screen. I am going to use the offset command to duplicate the square we have created. Activate the offset command. Set the offset distance to 0.25. Select the square we have created and we will now duplicate the selected geometry. Choose the inside of the square to make an offset copy. We need to make 5 copies of the square. Hit the spacebar to end the command. Next, we'll create the polygon that's rotated and passes through the corner of the first square we created. Activate the Polygon command. We still want to have a 4-sided shape. This time we will use the center of the polygon option. In the status toolbar, switch on the snap option so we can snap more easily. Click on the center of the squares we have created. We need to choose a creation option for the polygon, whether we want to identify the polygon as inscribed in circle or circumscribed about circle. Choose the circumscribed option. Now we can snap to the corners of the outside square. This assures the polygon is rotated and passes through the four corners of the first square we created. All we need now is to create the parallel lines. Activate the line command. We will first create one vertical line passing through the two corners of the outside polygon. Select the two corners to create the line. Right mouse click once to bring up the option list. Choose Enter to end the line command. In the status toolbar, switch off the snap option. Activate the offset command. Enter offset distance 0.25. Select the vertical line we just created. Click on the left side of the line and create one offset line. We need 5 parallel lines on both sides. Right mouse click once to bring up the option list. Choose Enter to end the command. Now we'll trim these lines, removing the portions we don't need. Activate the trim command. For the trimming boundary, we'll pick the outside polygon and also the first square we created. Right mouse click once to accept the selection. And we'll first trim the extra portions on the outside. Since we have selected the first square as the trimming boundary, we can also remove the portions that are inside the region. Right mouse click once to bring up the option list. Choose Enter to end the trim command. We can repeat the same procedure to create the horizontal lines. A faster approach would be to use the copy command and/or the rotate command. With AutoCAD, the rotate command has a copy option. We'll therefore use the rotate command. Activate the rotate command. To select the objects, we'll use the selection window. Click once with the left mouse button to set the first corner of the selection window. Move downwards and towards the right to set the second corner of the selection window. All the objects completely inside the window will be selected. We'll also want to select the bottom set of lines. Right mouse click once to accept the selection. In the status toolbar, switch on the snap option so we can go to the center of the design more easily. And so now we can actually rotate the selected objects and see the rotated image. There is a copy option with the rotate command, so right mouse click once to bring up the option list. Choose copy. Now type 90 degrees and hit Enter to create the rotated copy. We have completed our design.